So the original Arkstorm, and I'm sure you've got a great description of it in it, we put together, over 10 years ago. And USGS led this, and they were looking to understand the impacts of a catastrophic storm that has happened in the historical record. So we have had massive storms on the order of 30 to 40 days of precipitation in the historical record about every 200 to 300 years. And the one that most people remember having hit, or not remember, but most people know from historical stories that hit, was the storm of 1861-62. And that was approximately 40 days of nearly continuous precipitation, series of atmospheric rivers that hit the West Coast. And it dumped so much rain in California in particular that it wiped out the entire economy of California and did substantial damage to Nevada. As a matter of fact, Mark Twain wrote about it. So we knew that these events had happened in the historical record, and USGS had a program that was looking at the scientific applications of risk reduction, they called it. And they were looking at major earthquakes and tsunamis and all these other things. And so they wanted, 10, 12 years ago to be able to do a scenario based on an extreme storm that wasn't that bad as the one in 1862, but made people think about it. So the original Arkstorm was put together by several climatologists and meteorologists, the scenario, and what it did was it concatenated two historical storms together from the historical record that we knew had major impacts. One had predominantly impacts in Southern California, the other had heavy impacts in Northern California. We made it what we call climatologically plausible. So it was a storm sequence that was meteorologically sound. It could happen. And we took that sequence, which was only 23 days, and we took the atmospheric conditions, we put it through some hydrologic models, and then we worked with communities. USGS did a lot of program in California, and then they funded us to do a specialized project called Arkstorm at Tahoe, which focused on the impacts of that storm in the Tahoe Basin up in the mountains, because most of the work in California hadn't really considered what happened in the headwaters regions, and then what the spillover was into you can edit that out.
It was funny though.
New teams. What the impact was, they looked at what the impact spillover was into Nevada. So we did this project where we worked with communities all the way from Tahoe region and water suppliers in Tahoe. We worked with communities in Carson and Reno and the tribal communities to understand what the impacts of that storm sequence would be, that flooding sequence. Now, we were doing this in 2012, 2013, and it was very timely because, of course, the biggest flood of record in our area in northern Nevada was in 1997. And that resulted in a lot of major damage, but a lot of major changes. So one of the most notable ones was the 1997 flooded the National Weather Service, and it flooded the Emergency Operations Center. So both of those facilities are now located up on the hill next to DRI, not down in the valley next to the airport. So there were some major changes that the community had adapted to during that 1997 flood. So it was very easy for us to say, okay, here's another storm sequence scenario. We want you to look at this. In some cases, that was 2 to 3 times as bad as 97, and certainly longer. So that was the original scenario. That really got people thinking about extreme storms that go on for many days as a sort of extreme event, a catastrophic event that could cause massive disruption. Like they think about earthquakes and they think about, major wildfires and that type of thing. So it really put extreme storms into the vernacular of emergency response planning. Not that they hadn't been doing it before, but it focused their attention that this is a scenario that could happen and it could have major impacts in our communities, extended impacts over long periods of time. And so they, many of the communities work with got very engaged in this planning. And in particular, Tahoe, the communities in Tahoe were really stunned when they saw the scenario because it was a scenario that would have dumped a lot of snow and then rain on snow, and then it would have caused a lot of disruptions to water supplies, water handling. And one of the key things that we got from the communities up there was they all of a sudden realized that if roadways were closed to get people into the basin during the course of the storm, they wouldn't have any workers because so many of the workers lived outside of the basin because it's so expensive. And one of the actions that was taken by IFGID in Incline Village that runs all the utilities there was to put in basically create a bunkhouse. So if they knew after the original Arkstorm of Tahoe, they knew that if there was a storm being forecast, then they would make sure they had people staying in the bunkhouse so that there would be somebody there to operate the water supply system and the wastewater treatment system and all those types of things. So there were some major things that came out of that. But one of the things that was a question that came in the course of doing this was people started to ask us what would happen with climate change. And this was 10 years ago. And we explained that, the scenario we did 10 years ago really wasn't a climate change based scenario. It was a historical storm based scenario that we made worse by hooking two together, but it really had no information. We had no information about climate change in there. And so we started a project, a few years ago to really understand what a storm scenario would look like if we were able to extract it from the climate projections. So we really had all the meteorological conditions under global warming, and we ran it through the newest version of the weather models that we had, so that we could get very precise, 3-kilometer resolution meteorological conditions. So precipitation rates and winds and snow water equivalent and temperatures and everything like that on a grid, a 3-kilometer grid. That kind of information allowed us to really say what climate change would do to these kinds of storm-like sequences. And so that brings us to what we call Arkstorm 2.0. And now we're doing a similar engagement with the communities in Nevada. We're looking at what we call Arkstorm at the Sierra Front. So we're using that brand new climate-driven based scenario. It's been run through some hydrologic models, so we have information about stream flows and some inundation for the Truckee Meadows area. And we're looking at the Truckee River, the Carson River, and the Walker River basins, and what this new scenario would do. And we're putting it in the context of the original Arkstorm, and we're putting it in the context of things that people remember, like 1997, which is now a little further away, but they remember 2023, which caused a lot of flooding. They remember 2017 that caused a lot of flooding. So putting it in that historical context, so we're able to say, this is what happens with global warming and making these scenarios more extreme. So the new scenario is a 30-day event. It's still less than the 1861-62 by a lot, but it does have extreme precipitation events. Of course, the temperatures are warmer, so a lot of the precipitation is coming as rain, not snow. And it also has a lot of precipitation, what we call spillover. So that means it's actually precipitation into Nevada, into the lee side of the mountains. And this is really getting people to think about it. The other big thing they asked is what would happen if these extreme storms happened when we had wildfire burn scars. So now they're interested in what we call multi-hazard planning. The connection between, okay, there was a wildfire in this area in the summer. We put an extreme amount of precipitation on it. We get landslides, debris flows, causing major disruptions to communities, which we know have happened all over our area. And we also know there are other things coupled with that, chemical contamination in the soils, heavy metals, all those sorts of things. So we're looking to understand how impacts are now coupled from the wildfire sequence to the extreme storm sequence. The nice thing about working in northern Nevada is that northern Nevada emergency planners, resiliency planners, that kinds of things, they understand the concept of extreme events. Nevada's a land of extremes. We're the driest state in the union. We're either seem to be in drought or we're threatened with floods or, not much in between. So emergency responders also have a lot of connections with each other because, the communities tend to be smaller and they have a lot of shared responsibilities. So one of the things that I think got them really enthusiastic was that this was a scenario that allowed them to test how different parts of the response community need to be working together. So, it's not just simply dealing with, the medical emergency people or the, road clearing people. It's a combination of all these folks. And because these storms are not punctuated in a short period of time, like an earthquake, it's not over in a few minutes or a day or two. It's something that could go on for 30 days, or longer. So they're testing now, very enthusiastic about using this scenario to test how do they get through this long duration event, which they also know will have a long tail for recovery. But even just getting through the long duration of the event, everything from how do you keep people focused and not totally fatigued after day 6 or 7 of dealing with this? How do you keep people focused when the weather forecast may not be able to tell you? Nobody's going to be able to say at the beginning of this event it's going to go on for 30 days, right? You're going to get a forecast and they're going to say, oh, well, it looks clear for the next few days. And there may be something on the horizon. Oh, it's getting closer. Oh, it looks like we're going to have substantially more precipitation. So how do you deal with that uncertainty when you don't know what's going to happen next? And then how do you get sectors to talk to each other? And in particular in Nevada, this is a really big deal about getting the public sector and the private sector better coordinated. Because of course we've got some critical assets in the Reno area. We have the industrial park. You have Tesla. You have, iCloud. You have all of these really critical functions that need to be able to be integrated into the public response. And so getting more connections between public and private sector is really critical. And the other thing is that I think is why the timing is so good right now is that people learned a lot from COVID. There was some really, the positive thing that came out of COVID was an awareness that massive impacts to regions can disrupt economies, they can disrupt services, they can disrupt people's well-being. You've got a lot of vulnerable populations that people really hadn't understood beforehand. Supply chain logistics, all these types of things. And so this scenario allows us to sort of push the envelope. I mean, it's obviously not a global impact, but if you have a storm sequence that substantially impacts the entire state of California, you're going to disrupt a lot of services into Nevada. And so the enthusiasm is great. We're working directly with the Nevada emergency manager, Dave Fogerson. We're working with DHS CISA, the protective security advisors for the state. We're working with the National Weather Service at Washoe County, emergency managers, people who are connecting us to the resilience planners in the private sector. So there's a lot more enthusiasm to look at this. And the area that we're working in, the Sierra Front area, people know they need to plan for it. And sometimes even more so than California, because we know we're so close to the mountains that we understand that what happens in the mountains is going to have a direct impact in us, in a short period of time. If it's rain, or it's rain on snow, we have a really high percentage chance of flooding. If we don't have warnings for that floods, we can have massive disruption again. So I think it's actually easier to work in Nevada on this, and people are really enthusiastic to merge it into their emergency planning and also into the long-term tail planning, what we call resiliency planning. So how much disruption cumulative would you have in the area, and what does that look like for future community planning? Not necessarily, part of that is recovery for the event, but part of it is, do you really want to do things like keep building communities in floodplain areas? Those are big questions. So one of the things that's new about the new project, using the new scenario, is that we are now able to use a lot more data and models than we had before. So one of the things that our sponsors, USGS, was particularly interested was understanding how these kinds of storms disrupt tribal communities and underserved communities. And in the last 10 years, I just alluded to, in the last 10 years, we've had a lot of building in our area. And some of that building has taken place in areas that were at one point declared wetlands. Mm-hmm. And so we have communities that may be at risk. So we're able to use layers of data that we didn't have before. So socioeconomic data, like demographics, obviously using some census data, looking at things like communications and services to those communities. We've also looked at, and probably one of the newest things that we've really identified is the impact not only on to critical resources, but in the case of the tribal communities, the impact on cultural resources. So many of the tribes are heavily dependent, Fairman Lake, heavily dependent on what happens in the lake and the state of the river for the fish that are very important to their communities. The Washoe people, very dependent on the resources from the forests in the Sierra Forest. And these kinds of storms can really disrupt and have major cultural impacts as well as economic impacts. And the other is to understand how these communities have a voice in the planning process and the response process. So one of in the previous Arkstorm at Tahoe, we had a workshop which we did with just the tribal emergency managers. And we listened really carefully to them. And they had a level of communication issues and um, and challenges that were very different from the surrounding community, and we brought that to the forefront. And another that's another lesson from COVID. Many communities that didn't have tribal communities throughout the West that didn't have access to running water and things had a hard time responding when they were cut off. And so I think there's what we're trying to do is introduce that kind of socioeconomic information to the emergency planners. So it's not just simply flood inundation maps and critical infrastructure, but we're building tools that allow them to see these different layers. So look at the demographics, look where critical services are, look at what the population center income base is, so you know whether or not you potentially could have people cut off from any kind of income that may need to be sustained with food supplies, water supplies, those kinds of things. So it's getting people to think down to the community level rather than simply just disruptions of infrastructure and the economy, which is sort of the two big things we usually think about in emergency planning, because we certainly hope it has an impact on policy. And we know that major events like the 1997 flood, like I said, had major impacts on policy. They had to relocate places. They had to put in redundancy for gas lines and critical infrastructure lines. So there were some major changes that were done after 97. I think one of the things that we are encouraging people to think about policy-wise is, obviously we're informing them about areas that could be extremely at risk, and that the concept that we used before, the old language you used before about the 100-year flood, the 500-year flood, doesn't mean anything anymore. You have to understand that we are in a vulnerable area. These events could happen at any time. You could have, two of these events happen 2 years in a row, or you may not see one for, 50 years. But nonetheless, you have to understand, as you're building out the community, as you're building out water supplies, as you're building water treatment plants, as you're thinking about agricultural communities, you have to be able to say, these kinds of events are real. And if you're planning or building emergency response services, you're going to have this could go on for a long period of time. So this scenario that we have would have been like if we took all of the precipitation we got in 2023 and we condensed it down to about 25 to 28 days.
Oh my goodness.
Okay. We have some incredibly unique natural resources. And, in a lot of cases, the tribes have been absolutely pivotal in taking stewardship for those natural resources. And so how can we make sure that they're sustained, but they're also part of the solution? So, but the concept of what we're doing, taking a climate-driven scenario, integrating that with, taking the meteorological information, using that as input into hydrologic models so we can understand how the rivers and streams behave, whether they have large amounts of infrastructure or not. And then overlaying that with all the socioeconomic demographic information. That's something that is a framework that can be moved to any area. Doesn't mean they have to be just atmospheric rivers, because of course the big storm that disrupted Vegas last year was Hurricane Hillary.
That's right. That's what that was. Yeah, that's right.
It wasn't an AR event. It was actually a Pacific cyclone, and it came up, and the pattern that it hit Vegas. It basically missed Reno. It caught Elko, and then it actually moved north and hit us in Montana. So that notion of how do we understand extreme storm scenario planning and what are the key factors that you need to understand. So, for instance, obviously, I'm also affiliated with the Montana Climate Office, and a couple of years ago, we had an extreme AR that came in June. So that's into the Pacific Northwest. It came into Montana and it hit just at the point where they were maximum snow melt from the snowpack.
Oh, wow.
And that's what flooded Yellowstone, shut down Yellowstone, flooded the parks here. It was a short duration, it was 5 days, catastrophic flooding across the state of Montana. And so there you have to get people to say, okay, now we have to deal with these kinds of extreme storms that happen on high snowpack. Or you get, in our case in Northern Nevada, you get the big difference is it going to be rain? Is it going to be rain on snow? Is it going to be all snow? So in 2023, there wasn't a huge amount of flooding in Reno. That's because the winter was so cold that we didn't get a lot of these rain on snow events. So you can take this framework and have it used in different areas. It's a way of thinking about how do you deal with the extreme events, and then what are the other things you want to think about. Where have you had wildfires? What are the what we call antecedent conditions? So are your reservoirs full or are they empty? Are your snowpack high or is it bare ground? All those kinds of things are things you can do regardless of how you extract the storm sequence. And so it can be easily used in other areas.